Okay, we're going to talk about neutralization reactions. Neutralization reactions are reactions that occur between an acid and a base. As you might remember, acids produce hydrogen ions in solution. And a strong acid, like hydrochloric acid, breaks up into, completely dissociates into hydrogen ions plus chloride ions. You may also then recall that bases dissociate to produce hydroxide ions. So strong bases like sodium hydroxide break up into sodium ions and hydroxide ions. So in a neutralization reaction, what happens is that the hydrochloric acid and sodium hydroxide dissociate to make hydrogen ions plus chloride ions plus sodium ions and hydroxide ions. What happens is that the hydrogen ion and the hydroxide ion combine to form water. And I'm going to write that as an H and an OH so that you can see that the hydrogen ion here produces this H, and this OH together produces the other half of the water. But the sodium ion and the chloride ion remain dissociated. And since they're the same thing on both sides of the equation, they're what we call spectator ions. So they cancel each other out. And therefore our net reaction comes down to H plus OH minus yields H2O. So this hydrogen ion comes from the acid. This hydroxide ion comes from the base. And we get water formed. So if there are exactly enough hydrogen ions and exactly enough hydroxide ions, the two of them combine to form water with no hydrogen ions or hydroxide ions left over. So when the number of hydrogen ions equals the number of hydroxide ions, we call this neutralization. So it becomes neutral when the hydrogen ions equal the hydroxide ions. So how do we use this in solving problems? The question is, what volume of 0.1 molar hydrochloric acid solution is needed to neutralize 25 milliliters of 0.350 molar sodium hydroxide solution? Well, we can't do anything without an equation, so we have to write it out. Hydrochloric acid and sodium hydroxide react to form, as we just saw, H2O plus sodium ions plus chloride ions. Everything balanced. Hydrogen here makes one of these hydrogens. The other hydrogen, remember, comes from the hydroxide group, so we got two of those there. And the oxygen comes from the NaOH. Because remember, this is HOH, same thing, acid and the base. And then we have the leftover sodium and chloride ions that are undissociated. So we got one of each of those. Everything's balancing. Everything looks kosher. So, in order to neutralize these guys, we have 25.0 milliliters of 0.35 molar sodium hydroxide. Make sure we indicate that these are milliliters of sodium hydroxide. because we need to make comparisons. We're doing some stoichiometry here. We need a mole-to-mole relationship, so we have to get these milliliters into moles. So the molarity of this solution says that there are 0.350 moles of sodium hydroxide for every liter or 1,000 milliliters of solution. So the milliliters of NaOH cancel, and now we're in moles of NaOH. Now we know from our reaction here that the moles of hydrogen ions have to equal the moles of hydroxide ions. So therefore we have 1 mole of NaOH for every mole of HCl. And the question is asking us to find what volume of this solution do we need. Well, we know how many moles of hydrochloric acid we've used. Oh, don't forget to cancel moles of sodium hydroxide. And using our molarity, we know that there are 0.100 moles of HCl for every 1,000 milliliters of solution. Now, moles of HCl cancel out, and if we look closely, we see that this 1,000 cancels out this 1,000. The only unit we have left over is milliliters, so I'm thinking we're probably right, and it's time to get out the calculator. So 25 times 0.35 divided by 0.1 equals 87.5 milliliters HCl. Ta-da!